device that is especially useful for measuring curved surfaces like spheres is known as a micrometer caliper. And so let's talk about the basic functions of the micrometer. Okay, first of all, there's the locking mechanism, and we want to make sure that he's in the open position. That's what I'm pointing at right now, so he's free to move. If your caliper does not automatically turn on, then there's the on-off button that I'm pointing at right here. And if it's also not zeroed, so it's similar, you might say, to the vernier caliper in several respects. There's an ABS button which you can press, and that will zero out your micrometer while it is closed down. And there's also a millimeter inch button that allows you to toggle back and forth. And so, well, we once again want to be on millimeters. And notice the precision here. This is a device that's even more precise than the vernier caliper, down to 3 decimal places. So you can read down to not only a hundredth of a millimeter, but a thousandth of a millimeter. And now, again, the reason why you would want to use micrometer caliper as opposed to vernier caliper is it's real useful for measuring curved surfaces. So let me show you an example of that. Now, over here, what I'm doing is anywhere along here, we have a rotating spindle. And it really doesn't matter much where you rotate it. I usually use the largest section to get generally to where I need to be. And so what will be real useful in this case is when we're dealing with spheres. So you would not want to use a vernier caliper to try to measure the diameter of a sphere, because you might only be measuring a chord or not the full diameter, whereas with the micrometer caliper you have a much better chance of getting the full diameter. And so the way that you do that is, as you get close to getting with just gentle pressure, you use the outer tiny spindle, and you should have heard just one click right there. Alright, so there can be a tendency to want to rotate this and hear several clicks, but it's recommended that you just hear a click or two, and that way you know that you're secure down on your sphere. And so we can see in this case that we have a reading of 12.700 millimeters, which is quite precise indeed. And it's always a good idea to rotate your material around, so if you're taking subsequent measurements of the diameter, you're not pressing down on one diameter all the time, but it's a good general practice to rotate the sphere around, let's say in 3 dimensions, so that you can get at least 3 readings that vary across the surface of the sphere, and by so doing you can get its average and use the appropriate formula for the volume of the sphere. Calculate its volume, and knowing its mass, you can then figure out the density, and by so doing come up with a reasonable understanding of what the material is. And as we were saying earlier, when it comes to spheres, you can see that if we suppose all of these are made of, say, steel, that despite the fact that they're different size spheres, we should come up with reasonably close values of the same density for all of them, despite their different sizes. So again, we use a micrometer caliper typically exclusively for spheres. The vernier caliper will use much more in this class as we encounter many of the other shapes more often, but this is usually your best tool